Hello, Mr. Martino here from your favorite teacher. Today we're going to continue our lesson on indices. And just to recap, indices include square roots, cube roots, and powers. We've already done an initial lesson on indices, and we're going to continue with index laws. And today we're going to look at, first of all, negative powers, or another way to say it is reciprocals. And let's take a look at what we mean with our negative power law. If I have a power that is a negative power, in this case any value a to the power minus n, it is going to be the same thing as 1 divided by a to the power n. So in other words, I get rid of my negative and I put 1 divided by the same answer to the power that is there. So all that happens is we switch the negative for 1 over. So as an example, 5 to the power minus 3 is the same thing as 1 divided by just 5 to the power 3. The negative disappears and we have 1 divided by. 4 to the power minus 2 is the same thing as 1 over 4 to the power 2, or 4 squared. Finally, 6 to the power minus 1 is the same thing as 1 over 6 to the power 1. But 6 to the power 1, we don't write power 1, we just call it 6. Okay? So, take a little look at that and try and digest it. Second thing we need to do with index laws is we need to be able to simplify fractions that have powers. So let's assume I have a fraction, some number a over another number b, which is a divided by b, and I put that whole thing and raise it to a power n. It will be the same thing as if I just had a on its own to the power n divided by b to the power n. In other words, I raise the two numbers a and b on their own to the power that is outside the bracket. And then I can always simplify that further if necessary. So as an example, if I have 2/3 or 2 over 3 to the power 3, it'll be the same answer as if I had 2 to the power 3 divided by 3 to the power 3. Or if I have 4 divided by 5 and that whole thing has to be squared, it means it's 4 squared divided by 5 squared. And this now is, say, 1 over 6 to the power 4. That's the same thing as 1 over 6 to the power 4. But notice that I don't write that 1 as 1 to the power 4. I just say it's 1 because 1 to the power 4 is 1. Okay? So that's if we had a fraction and we raised that fraction to a power. So we've looked at negative powers, we've looked at fractions, and now we're going to combine both of those things. So fractions with negative powers. So I have a over b to the power minus n, and that now is the same thing as the reciprocal of a over b to the power n, which is like flipping the fraction. It turns it upside down. And then I expand it in a similar way to when I just had a fraction raised to a power. So a over b to the power minus n is flip the fraction b over a to the power n. The negative power goes away. And I just expand now b to the power n, a to the power n. So let's take a look at some examples, and we'll try to slow it down as we go through. So I start off with 3 over 4 to the minus 2. So the first thing I do is I turn the fraction upside down, so I will have 4 over 3, and then I just raise it to the power 2. Now I can expand it, and I will get 4 squared over 3 squared. So just remember what you need to do. You need to first of all flip it and then expand it. I can evaluate that by saying, what is 4 squared? 4 squared is 16. What is 3 squared? It's 9. So if I'm asked to evaluate the original expression, what is 3 over 4 raised to the power minus 2? My answer, if I need to evaluate it, would be 16 over 9. Let's take another example. I'm asked to evaluate what is 2/3 to the power minus 5. So first step, I turn it over. I get 3 over 2 to the power 5. I then expand that. I get 3 to the power 5 divided by 2 to the power 5. And if I'm asked to evaluate that, I multiply 3 by 3 by 3 and do it 5 times, and I get this answer, 243 over 32. You can check to see that that's correct. And that's what would happen if you had to evaluate those expressions. Okay, so time for us to do some work on our own. So can we try and do those expressions? Remember, if you need to actually just expand it, you expand it. And if you need to evaluate it, you need to actually put a number at the end of it that is a value of these things. You can always keep it in a fraction form if necessary. So I expect that you should take between 12 to 15 minutes doing these questions. So you can pause the video, or we can go on to the answers when you've finished. So we can now go on to the answers. That's what the answers would be if we had to evaluate all of those expressions. Hope this was helpful. This was Mr. Martineau for your favorite teacher.